Okay, Calculus 1, Algebra Review Part 2. So here's the second worksheet. There are 6 problems on this, and you have a graph on this one. So we're going to make sure we remember how to interpret graphs. So number 1, the question says, state the domain and range in interval notation. So we have this it looks like a transformation of a square root graph. And so when they give you a picture of a graph, it's super easy to interpret the domain and range because you just look at what it's doing. So I'm just sort of sketching this. This is what it looked like. And this point right here, if you look at the units on the graph that you were given, you have to pay attention to the markings. And so each little mark is halfway. It's a half a unit. And so this is 2, and so this is 1. And so these are half units. So this is going from x is negative, and these are negatives. Is that negative? Yeah, that's negative 2.5. And then we're just going to say, we'll just make an assumption that this has got an arrow on it and it goes on to infinity. There's our domain. The range is how low does it go to how high does it go. So the lowest y value that it achieves is 0, and the highest that it achieves is as high as it wants to go. It looks like it's going to infinity. State the value of g of negative 2. Well, you just go over to where g is negative 2 on the x, and you go up to the y, and you say, well, what is that y value? So g of negative 2 appears to be 1. It appears to be hitting here at 1. And what is g of 2? Well, then you would go over here to where it's 2, and you go up here and say, well, what does this y value appear to be? And so g of 2 appears to be 3. That's where it looks like it's hitting. Then it says estimate the value of x such that g of x equals to 0. Estimate the value of x such that g of x equals to 0. So what they're asking is when g of x, which is the y value, is 0, what x value of this function gives you that? Where is this y value 0? Well, right here, when it's touching the x, this is where it's equal to 0, the y value. Well, what is the x value that goes with that? Well, right there, x is equal to negative 2.5 when so g of negative 2.5 is equal to 0. So when x is negative 2.5 is how you would interpret that. The next question says, why is g 1 to 1? Oh, maybe I meant to say, is g 1 to 1? Okay, is g 1 to 1? Let's ask that. Is g 1 to 1? Yes, it is. What does that mean for something to be 1 to 1? To figure out if a function is 1 to 1, you apply the horizontal line test. So what you would do is you would say, you would look at the function. So let me erase some of this other stuff that I put on here. So here's this function. You're like, can I pass a horizontal line through here and make it touch more than once? And if you cannot make it touch more than once, it only touches one time, then that function is called 1 to 1. So we'd say, yes, g of x is 1 to 1. It passes the horizontal line test. Now, why do we care if something's 1 to 1? Well, if something's 1 to 1, then an inverse function exists. Then you can find an inverse function for g of x. That's what we know. Then it says this, is g even, odd, or neither? So to determine if a function is even or odd or neither even nor odd, you can look at it graphically or algebraically. So graphically is really the easiest way to look at it. If something is an even function, this is an example of a function that's even, x squared. When it's graphed, it looks the same on both sides of the y-axis. It's got y-axis symmetry. If a function is odd, it's got what we call origin symmetry. And it looks the same way if you flipped it across the y, reflected it across the y, and then the x, or vice versa, first the x and then the y, it would land in the same place. So functions like this, x cubed, functions like this is a terrible drawing, but 1 over x, those are odd functions and they have origin symmetry. So if we look at the graph that we're given here, if we were to reflect this across the y-axis, yeah, across the y-axis, then it's going to look something like this. And then, well, first let's just look across the y-axis real quick. If I reflect this across the y-axis, does it look the same on both sides of the y-axis? No. So this is not an even function. It is not an even function. Then the second test would be odd. Reflect it across the y. Okay, if we reflect it across the y, it'd look like that. And then you take this and reflect it across the x. And if we reflect it across the x, it would look like this. And did this green line land in the same place as the original function? No, it did not. So we would say this is not odd. It's not odd, it's not even, and sometimes people call that neither. So it's neither one. F, estimate the value of G inverse of 1.75. G inverse of 1.75. G inverse of 1.75. Okay, what we are asked to do here, how can we figure that out? Well, we could go through all the steps and say, well, we don't know this function, but if we did, we could do the 4-step process to find the inverse of g of x, okay, and then we could evaluate it. But here's one thing we could do given the graph. One thing that functions and their inverses have in common is that, or have a characteristic of, is that the domain of one is the range of the other and vice versa. So what they're asking us to do is say, the input of g inverse of x would be the x in this function is going to give some output y. But if we're looking at g of x, then we look at the y to determine the x because the domain and the range are switched. So if we want to know what the inverse of 1.7 is, we go on this and we go up to where 1.75 is, wherever this is, and we say, well, what is this x value right there? And that's going to tell us what the inverse, g inverse of 1.75 is. So let me look at the graph. If I go up to 1.75, it looks like it is about hitting at, maybe I didn't draw it, when I look at this, it looks like it's about hitting at -1. So I would say that it's hitting the x value at -1. So I would say g inverse of 1.75 is -1. All right, that's number 1. Let's look at number 2. It says state the domain and the range of each of these functions. And so I gave you a few functions that have domain issues. So the first one is, for number 2, the first one is f of x, which is 5 over 2x plus 1. And so this particular function has the issue of it's possible to divide by 0 because it's a division problem. It's a rational function, which is a fraction function. Every fraction is a division problem. So you look at it and say, is it possible that I could divide by 0? Is it possible that the domain could equal 0 at any time? So let's look at that the denominator could equal 0 at any time. So yeah, I think it is. It's got an x in it. Let's see. If we set this equal to 0, could we get a value for x that's real? Subtract 1. Divide by 2. Yeah, the domain could equal 0 when x is -1/2. So we can't let that happen. So what this means is every other x value is okay to go into this function except for this. So in interval notation, this means from -infinity to -1/2. And I use a parentheses there that's really important, not a bracket, because a bracket means it equals -1/2. We can't let that happen. We union this with -1/2 to infinity. So basically, here's a picture of the real numbers on the x-axis. Here's 0. Here's -1/2. What did we just do? We included everything on this line except for this one little value. We hopped over -1/2. Okay, how about B? We have to find the domain of this guy. All right, here's the question. This is square root functions. Where do square root functions have issues? They have issues when we're trying to take the square root of a negative, because the definition of the square root of -1 is equal to the imaginary number I. We want to stay out of that region. So as long as what's under the square root, which this is what happens to be under the square root, is greater than or equal to 0, then we're okay. So let's just see what this is. This is a quadratic function, and the graph of this is the sketch of this is a parabola. So I'm just going to think of it this way. This is a parabola. The coefficient from the x term is negative. This is going to be facing down. Let's find out what are the zeros. Where would this equal to 0? We could solve this little quadratic equation by taking the square root. We get x squared is 2, and x is equal to plus or minus the square root of 2. So what this means, basically, is that we have some quadratic function like this, and that this this value is negative square root of 2, and this is the square root of 2. So here's the deal. As long as 2 minus the square root of x squared stays positive or equal to 0, we're okay. What x values does that happen for? It happens from here to here. So the domain of this guy is as long as we're in this part. So that means as long as x is from negative square root of 2 to positive square root of 2, we're in good shape. This is the domain of h of x. All right, let's look at the domain of m of x. And it is the natural log of 3x plus 2. So if you remember logarithmic graphs, this is a basic logarithmic graph where x is 0. And it's got this little x-intercept at 1. It hugs the y-axis and then begins to increase. The domain of a log graph is for x is greater than 0. It has to be positive. So what that means is whatever we're taking the log of, which happens to be 3x plus 2, it has to stay positive. And so how I say stay positive is I say you stay greater than 0. So I solve this little equation for x, and that will be the domain for this function. So I subtract 2, divide by 3. So as long as x is greater than this, we're in good shape. So the domain for m of x is going to be from negative 2/3 to infinity. And again, it's very important that I use a parentheses there because that means doesn't equal negative 2/3 because it's not allowed to equal 0. All right, so that's number 2. Number 3 is finding the inverse of a function. So let's just go through that little 4-step process I was referencing earlier. Let's get this here. How do you find the inverse of a function? Here are the steps. Number 1, you replace f of x with y. Number 2, you interchange x and y. Number 3, you solve for y. Number 4, you replace y with f inverse of x. So that's the 4-step process you've heard since college algebra. And so now we're about to apply that. Only this is one that involves a little more. This is number 3. This involves a little more algebra. It's fine. We'll be all right. First, replace f of x with y. Interchange x's and y's, so this is x is equal to 3y plus 1 over y minus 5. And now we have to solve for y. And so it's kind of messed up. So how I would solve for y is first I would kill my fraction by multiplying both sides by the denominator. So I have x times y minus 5. I multiply this side by y minus 5 and this side by y minus 5. So what happens over here is these cancel, and what happens over here is these get multiplied. Okay. And now I want to solve for y. Well, right here I need to free up this y term by distributing this x. Now let's get all of our y's on the same side. X, y minus 3y. I'm going to add 5x to both sides. It's 5x plus 1. Now to solve for y, I have two terms. If these were both whole numbers like 2y plus 7y, I would just add those together, but I don't have that luxury. I have xy minus 3y, so I need to factor out the y, leaving me with x minus 3 is 5x plus 1. Now to solve for y, I will simply divide by x minus 3. And so y, this is what y equals to, so the last step is to replace that with 5x plus 1 over x minus 3. And that is the inverse function for that. All right, cool. The next one is difference quotient. Difference quotient is this. F of x is f of x plus plus h minus f of x all over h. And they said find the difference quotient for this problem. And so number 4, they say, here it is, f of x is equal to x squared minus 3x plus 6. So in order to construct and simplify this difference quotient, we need to first figure out what f of x plus h is. We don't have to figure out what f of x is because they gave it to us right there. We're set. First, let's figure out what f of x plus h is. So right here, whoops, when you're figuring out what f of x plus h is, all you do is you go in and you replace every x with x plus h. We should square this, so this is going to be x squared plus 2xh plus h squared. I'm just distributed that. So what over here, this is kind of my scrap work where I'm figuring out what f of x plus h is. So this is going to be x squared plus 2xh plus h squared plus 3x plus 3h plus 6. All of this right here is what f of x plus h is. So all of this right here is what I'm going to put in for this. All right, now, then I'm going to put in a minus sign because that's part of the formula. But then I'm going to put in f of x. What will I put in for f of x? Well, what they told me it would equal to in the very beginning. What will I put in for h? I will just put in h. So right here is the constructed difference quotient. What did I put? I didn't mean to put that. Let me just say, this is the difference quotient. That means that this is the difference quotient. Quotient. All right, so it's f of x plus h, which is all of this stuff. X squared plus 2xh plus h squared plus 3x plus 3h plus 6 minus f of x, which is this, x squared minus 3x plus 6 all over h. This right here is the constructed difference quotient. Now, we need to simplify it. So let's distribute this negative to all of the terms in f of x. That's really important. This becomes a negative x squared. This is a positive, and this becomes a negative 6. Then we can collect like terms in the numerator. We have an x squared minus x squared, which will sum to 0. We have a positive 3x, oops, and did I mess this up somehow? Let me just see. Did I mess this up somehow? Did I mess this up somehow? I did. Let's see, what did I do wrong? Oh, right here. This is where I went wrong. I copied this down. This should be a minus 3x. So this should be a minus 3x, and this should be a minus 3h. So this should be a minus 3x, and this should be a minus 3h. So over here, this should be minus 3x, and this should be minus 3h. Okay, why I saw something was not going right is when you're doing difference quotient, the terms without after you do this step, all the terms in the numerator should have an h in them, and something was going wrong, so I knew I had made a mistake. Right here, negative 3x plus 3x. This will sum to 0. All right, and then 6 minus 6 sums to 0. So what do I have left? I have 2xh plus h squared minus 3h over h. I can factor out a h from the numerator. 2x plus h minus 3 all over h. Those will cancel. This is the simplified difference quotient for f of x. So that's how you would do number 4. All right, let's look at number 5 on the back. We are supposed to do some sketches. So this is reminding you how to sketch some basic functions. So let's just do that real quick. All right, let's see. A, sketch the graph of the given functions if we have f of x is equal to negative x squared plus 3. Okay, let's do that. Or we have g of x is equal to the square root of x minus 3 minus 4, okay? Or if we have the natural log of x minus 2 or if we have m of x is the sine of 2x plus 1. Okay, let's do these. Our graphs that we should know how to graph at this point. So let me just remind you how this goes. All right, this is the basic graph of x squared, which is a parabola facing up with its vertex at the origin. This negative outside means it reflects across the x-axis. This plus 3 means it's being shifted up 3 units. So if this is the basic graph, you should always think of the basic graph before you start shifting it. Across the x would mean down here, and then shifted up 3 would go 1, 2, 3. This is my new origin, and it's facing down. That's what that transformation should look like. Right here, this is a transformation of the graph. The square root of x minus 3, my radical symbol went too far. So it's the square root of x minus 3 minus 4. This negative 3 is in there messing with the function, indicating it's a horizontal shift opposite of what it looks like it should be. So this is going to go to the right 3, and this is going to go down 4. So we're going to go right 1, 2, 3, and down 1, 2, 3, 4. And so right here is our new origin. That's our new xy. And so the basic graph of the square root of x looks like that, basically. So this is where it's going to start, and that's what it's going to kind of look like. There's my sketch right there. The natural log of x minus 2. What is the basic function? This is a basic graph function. It's got this intercept right here, and this is what the natural log of x looks like. The log of a base bigger than 1 looks like. So this just means it's being shifted to the right 2. It's in there messing with the function, horizontal shift, opposite of what appears to be. So this is going to go to the right 2 units. So we go over 1, we go over 2. This is my new x-axis, or my new vertical asymptote. Then we're going to go to the right 1 if we want to see that little intercept. And so this is what this guy is going to look like. All right, lastly, this trig graph. So we still need to remember trig, and lots of times students think, oh, I made it through trig, I can forget about that, but here it is again. So let's think about a trig function. What have we got? Y is equal to a sine of bx. We could say bx plus c plus d, or minus c plus c. This is kind of the basic form, okay? So, and actually the b might be out here. Okay. So what you need to remember is a is the amplitude of our sine graph. And so our a is the number 1. It's going to be up and down between 1 and negative 1. B, what does this do? It affects the period. C is the phase shift, or the horizontal shift. D is a vertical shift. If you remember this from trig. So those are the elements. When I look at this, this is what I was given. What do I see going on here? Well, I have an amplitude of 1, okay. I have the number b, which will affect the period. Do you see how what I'm taking the sine of is just this right here? So I don't have this c, so there's no phase shift. There's no phase shift. But I do have a vertical shift up 1. It is being shifted up 1. Okay, so let's see. The amplitude is 1 to negative 1. How about the period? The period is always equal to 2 pi divided by b, or 2 pi divided by 2, because b is 2 in this case, so pi. So then the intervals that we're interested in marking on our x-axis will always be the period divided by 4, or pi divided by 4. So let's just see here. This is 0. I'm going to go to pi over 4, pi over 2, 3 pi over 2, pi over 4, let's see, pi over 2, 3 pi over 4, and pi. Let's go backwards. negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4. So I'm going to get 2 periods of this because the period's pi. So it's going to toggle up and down between 1 and negative 1. But this is what I know. It's really being shifted up 1. We'll handle that shift in a second. And it's easy to do with a whiteboard, so I might do it differently if I had on paper. But let's just go ahead. We'll do the vertical shift, this up 1, in just a second. First, let's just get our sign graph on there. There's no transformation. So at 0, it starts where a sign normally starts, which is at 0. So it starts here, and then at pi over 4, it goes up, and then it's middle, and then it's down, and then it's up. And if we were going to go backwards, we're down here, we're in the middle, we're up here, we're in the middle. So this is my sign graph. There's my x-axis label, there's my y-axis label. However, it is shifted up 1. That means you go to your y-axis and you can add the number 1 to each of these. So really, negative 1 plus 1 is 0. So really, right here is my x-axis. This is where 1 is, and this is where 2 is. So that is really what my sign graph looks like for that one. Okay, last one. Last one says, you save $3,700 to go on vacation during the summer since you will not be taking any classes. And we're pretending that you're allowed to travel this summer and that you're not stuck at home under COVID-19 restrictions. So we're making a lot of assumptions here about how life used to be. Okay, so after 1 week at your vacation destination, you notice that you have this much money left. After 2 weeks, you have this much money left. Express the approximate amount of money you have as a function of the number of weeks into the summer, assuming it is linear. What is the slope of the graph, and what does it represent? What is the y-intercept, and what does it represent? So this is just helping you remember linear functions, which you have talked about lots and lots. So linear means just this. It's a line. Y equals mx plus b. That's a line. Other ways of seeing a linear function is the highest power of any variable is 1. Those are linear functions. Those are lines. So those are nice and easy to work with. And so they went ahead and told us to model this with a linear function. So when you read the problem, they give you points. Hopefully you can hear some points. They say after you save this much money to go on vacation, since you will not be taking any classes, after 1 week, you notice you have this much money left. So they're starting to say after, they have something called weeks, and then they have something else called money. The number of weeks that have passed. How about that? And then the amount of money. Amount of money. So how much money do we start with when no weeks have passed? We start with $3,700. And then it says after 1 week, how much do we have left? We have $3,250. And then it says after 2 weeks, you have $2,800. It says express the amount of money you have as a function of the number of weeks. The amount of money you have, we're going to express this as a function of this. So f of x or y, the function of the number of weeks. And we want it to be linear model. So we're going to make it look like this eventually. That's going to be our linear model. Y equals mx plus b, where y stands for the amount of money we have, x is the amount of weeks that have passed. So in order to write the equation of a line, you got to have 2 pieces of information. One is the slope of the line, and the other is any point on the line at all. So let's just see. How do we calculate slope? It is the change in the y values over the change in the x values. And so we didn't have to figure out what kind of model because they just came out and told us linear. They didn't say exponential or quadratic, they said linear. So we know what to do. The change in the y, y2 minus y1 over x2 minus x1. So what we would do is pick two of these points. It doesn't matter which two. I'm going to go for easy. So usually if you use something with a 0 in it, this is easy. These are points, right? 0, 3,700, 1, 3,250, 2, 2,800. These are points, okay? So I'm going to choose the first 2 points. So the slope is going to be 3,250 minus 3,700 over 1 minus 0. This minus this over this minus this. And so that gives me, what number does that give me? That gives me negative 450. What does this mean? Well, what were the units of y? The units of y were money, so it's negative $450. What were the units of x per week? We are spending on our vacation about $450 per week. So we're losing that much money each week. So that's what that means. So that's what the slope represents. We have to, what is the y-intercept